Hello, welcome to our today's lesson. It is a lesson on Form 2 work, equations of a straight line. I'm just getting prepared to start off the lesson. So if you are joining me, make sure you stay until the end. So equations of a straight line. So if you're joining me from YouTube, Facebook, TikTok, and Instagram, I take this opportunity to welcome you to my lesson. Today we look at mathematics Form 2, equations of a straight line or equations of straight lines. And I'm just waiting for 8:10 to start off the class. Equations of a straight line. So this is done in Form 2. So I'm live on Facebook, YouTube, TikTok, and Instagram. So if you can get me, give me a like. I'll know that we are together. And in case of any question, use the comment section on the platform in which you are watching from. So I'll start off by giving out what is expected of us in this topic. So under equation of a straight line, we talk about gradient of a line. Gradient of a line. So the gradient is at time known as the slope. Sorry, there's some helicopter passing by making some noise. So we also call it the slope of a line. So gradient of a line can be determined by being given 2 points, like for example 2, 1 and 0.43. So these are point P, Q, and we are expected to determine the gradient of a line given the 2 points. So what do we go about? How do we go about that? So we say gradient is represented by M, and we say gradient is given by the change in Y over change in X. And the change in Y means, if I talk about this point Q, the Q of the Y of Q, so 3 minus 1, so 3 minus 1, the Y part, divide by 4 minus 2, the X part, and I get this is 2 over 2, and finally this is 1. So 1 is actually the gradient of that line. 1 is the gradient of that line. That is getting the slope or the gradient of a line given 2 points. Then we talk about equation of a line. We can get the equation of a line given a point or given 2 points. Point 3, 1 and 0.43. I want to determine the equation of this line. I'll first get the gradient. I've said gradient is given by M is change in Y of minus 1 divided by 4 minus 3, and this is 2 over 1. So my gradient is 2. So using the gradient 2 and one of the 2 points, 0.31, and another unknown point xy, we can use 0.31 or even 0.43. I want to now find the equation of this line, and I'll say 2, the gradient, is equals to y minus 1 divided by x minus 3, and then I'll closely multiply, and I have y or I'll talk of y minus 1 is equals to 2 into x minus 3. So opening the bracket, I have y minus 1 is equals to 2x minus 6. Then this is y is equals to 2x, then minus 5. So minus 6 plus 1, you get minus 5. So under these, or on these, I've represented the equation in the form y is equals to mx plus c. So this is the form in which we say this is how we present the equation of a straight line in the form y is equals to mx plus c. Then having done that, we look at now, there are few other things we talk about under this part. We talk about parallel lines, and we also talk about perpendicular lines. So perpendicular lines make an angle of 90. So parallel lines have the same gradient, while perpendicular lines have the product of their gradient is equals to minus 1. So these will help us to be able to solve or help us able to solve problems that involve parallel and perpendicular lines. And with me, I have a question that involves that part about parallel and perpendicular line. And the question that I want us to go through is right here. I have read. So the perpendicular line will allow me to just have it like this. We have it's a bit disturbing. So we have, yeah, there we are. A perpendicular line y is equals to negative or y minus 4x plus 3 is equals to 0 passes through point minus 8, 5. So this is a perpendicular line to this. So the line we are being told is perpendicular to this equation. To arrange this equation in the form y is equals to mx plus c. And by that I mean we rearrange this equation and we'll have it as y is equals to 4x. So all of these get to the other side minus 3. And that way we are able to know or extract this as the gradient. And therefore the gradient is 4. So 4 by m2 should give us negative 1. The relation between perpendicular line, the product of their gradient is equals to negative 1, is negative 1 over 4. With that in mind now, we'll be able to come up with the equation of the line that is given. So the equation, so it passes through point negative 8, 5, and now we have the gradient as minus 8, x minus minus 8, and close multiplying we have 4 into y minus into x plus, and then we can then say or talk about opening the brackets. So we have 4y minus 20 is equals to negative x plus minus 8. Collecting like terms, we then get 4y is equals to negative x. So 20 to the other side, you'll have minus 8 plus 20, so minus 12. So this is the equation of a perpendicular to the line that was given by this equation. So we first found the gradient of this equation, and then the relationship between the product of the two gradient. We get the equation which passes through this point. And the other point is about parallel lines. So as we said, parallel lines have the same gradient, and with that in mind, they share the common gradient. That was done in a KCSE exam. That is question number 6 is this one. Question number 26 is this one. And then we'll get back. So I'm now going to attempt this question that was done in KCSE 2019. We have a line L1 passes through 0.33 and 57. Find the equation of line 1 in the form y is equals to mx plus c, where m and c are constant. So what you've been given is 2 points. By 2 points, it means we are going to get the equation of the line given the 2 points. How are we going to achieve that? So it basically means what we highlighted earlier. So we have 2 points, 3, 3, 0.33 and 0.57. 0.33 and 0.57. To find the equation of the line, we first get the gradient. And we've said, allow me to first of all remove this one because we have what we need to check. We have to get the gradient, m is 7 minus 3 divided by 5 minus 3. 7 minus 3 is 4. 5 minus 3 is 2. And this is equals to 2. So the gradient of that line is equals to 2. And then using the gradient 2 and one of the point 3, 3 and a known point xy, we can therefore get the equation of that line. How? And we'll say 2 is equals to y minus 3 divided by x minus 3. So cross multiplying, we get 2y minus 3 is equals to 2 into x minus 3. Then we have y minus 3 is equals to 2x minus 6. Correcting the like terms, we get y is equals to 2x minus 3. So minus 6 plus 3 itakuwa minus 3. So this equation is in the form y is equals to mx plus c. And that now we have answered the first part, that is asking about the equation in the form y is equals to mx plus c. So B, another line L2 is perpendicular to L1 and passes through minus 2, 3. So that other line is perpendicular to L1. And L1, we know its gradient. So this other line is perpendicular to L1, whose gradient we know. And we know the gradient of 1 is 2. And this line 2 passes through a point minus 2, 3. So it passes through a point minus 2, 3. And we know the gradient of the other line that is perpendicular. So in short, this is line 1, this is line 2. So we said perpendicular lines are related in that the product of their gradient is equals to minus 1. So 2 by m2. should give us minus 1, and therefore m2 is negative 1 over 2, negative 1 over 2. And then therefore with this gradient and this point we can get the equation of line 2. How? That's now what we are going to do. So we have it here. This is what we are going to get or to do. We have the point and the gradient, so we'll say y minus 3 over x minus 2. Remember the point is minus 2, 3. The point where this line 2 passes. So this is equals to negative 1 over 2. So close multiplying, we get 2 into y minus 3 is equals to x, negative 1 x plus 2. Minus will be plus. Then opening the bracket, we have 2y minus 6 is equals to negative x minus 2. 2y is equals to negative x. Then taking this to the other side, it will be added, so we'll have minus 2 plus 6 plus 4. So this is the equation of line 2. The question never specified in which form, so we can leave it. We can give it in that form. Moving on, we've determined the equation of line 2, the x-intercept of line 2. X-intercept, something else I never mentioned, and I'll mention that this time, that x-intercept, at x-intercept y is equals to 0. And when we talk of that, it means we substitute the value of y being 0 to this equation, and we have 2 into 0 is equals to negative x plus 4. Then this is 0 is equals to negative x plus 4, and we can therefore say x is equals to 4. So that is the x-intercept, and we can give the intercept as a coordinate. So the intercept therefore is 0.40. So it means this is where the line cuts the x-axis. The line cuts the x-axis. We call it the x-intercept. So at x-intercept y is 0. If we are talking about y-intercept, the value of x is the one which is 0. But in this case, we are not asked about this. So we continue with the next part of the question, and it says determine the point of intersection of line 1 and line 2, and you're given 3 marks. The point of intersection of line 1 and line 2. So I'll remind you that we had line 1 somewhere, so we need to bring it on board. So line 1 was here. So this was line 1 was y is equals to 2x minus 3. This was our line 1. Then our line 2, we found the line 2 as 2y is equals to negative x plus 4. So we are being asked about the point of intersection. In short, the point of intersection is where the two lines meet, and we are supposed actually to solve that simultaneously. So solving this simultaneously give us the point of intersection. And how do we do that? So we can use substitution method, whereby I'll talk of 2y, I'll insert this value 2x minus 3 is equals to negative x plus 4. Then I open the bracket, I have 4x minus 6 is equals to negative x plus 4. And then I correct the right terms, 4x plus x, when you take this to this other side. And then this is equals to 4 plus 6. So this is 5x being equal to 10, dividing by 5 and by 5, we get x is equals to 2. But you are not done yet. So we require to find y. So y from up here, y is equals to 2x. 2x. So we can insert this 2 minus 3. So this is y is equals to 4 minus 3, which is equals to 1. So therefore the point of intersection is a point 0.21, or the two lines will meet at 0.21. So anytime we are talking about point of intersection, we think about solving the equation simultaneously by using the method we are comfortable with. So that is the equation of a straight line by Teacher Mwangi. So I was live on YouTube, Facebook, TikTok, and Instagram. So you find my other work on YouTube. You can subscribe, share, give a comment, and like. Thank you for watching. We'll end our class there, but later the same will be uploaded on YouTube. Have a good night. Thank you.